This demonstration will use the file patient data in order to create box plots for patient wait times. Let's open the file and get rolling. Like before, we'll use wait time in column G, and we want to create a box plot. These were invented in the late 1970s by AT&T Bell Labs employee John Tukey. To create a box plot, we'll take a look at Graphical Tools, come down to Box Plots in the middle of the menu, choose Entire Table next, and we'll put wait time in as the Y variable. There's a box here to show the mean or not. Remember, the center line in a box plot is the median. That will show up as a black line. If we check this box, the mean will also show up as a red dashed line. We'll go ahead and click this and we'll check OK. Now you can't see the red line because it's directly on top of the black line. On a box and whiskers plot, remember that 25% of your data will be in the bottom whisker, 50% of the data will be inside the box, and 25% of the data will be in the other whisker. We have the minimum point, we have the maximum point. We also have the median and what's called Q1 and Q3. Those are quartiles. Again, this is kind of like getting in a helicopter, going up above a histogram and looking down. As we look at the center shape and spread, it's very clear where the center is. It's very symmetrical. So the shape, we know if we were to plot this out, would be very bell-shaped. This would be a normal distribution. And if any outliers ever show up in the data, they will be denoted by a special symbol on a box plot. So our quick conclusions right here would be that the center of the data is just under 30 minutes of wait time. The spread of the data will range anywhere from a little above 15 minutes all the way up approaching 45 minutes, and that the shape of the data would be a bell-shaped curve because of the symmetry we see in the whiskers. Where a box plot has an advantage over a histogram is when you want to start comparing multiple groups all on one chart. A box plot can be much easier to view than histograms. Let's recall the last dialog box, and let's do a box plot by office. Our conclusion from looking at this would be that all three offices look very symmetrical, and the averages of each office, while being a little off, aren't greatly off. If we could take a horizontal line and poke it through all of the boxes, we'll find later that there's probably not a large statistically significant difference in the averages. Also, as we look at the spread of the data, the spread from tip of each whisker to the tip of the other whisker is roughly consistent with each office. It would take a statistical tool like ANOVA, which you will learn later in the course, to tell us with any degree of certainty whether these are performing statistically the same or different. But from a quick glance at this graph, we can pretty much tell you there's not much of a difference in terms of the spread, shape, or center of data based on each office. So again, a box plot is a great tool to have to quickly compare multiple groups. If you have 3 groups, 8 groups, 10 groups, it's much easier to look at multiple groups on a box plot than, say, stacking up all those histograms or dot plots even to look at. So that's one of the advantages of this tool. Let's go back to the course.